Evaluating a piecewise function, it's actually not too hard because it tells you what to do. The rules are right here. So basically that's just saying if x is less than 0, then do this. And if x is greater than or equal to 0, then do this. So when it's asking to do g of 3, it's saying x is 3. So if x is 3, is x less than 0 or is x greater than 0? Well, obviously 3 is greater than 0, so we're going to go ahead and use the second one. So we're going to use this 5 minus x. So 5 minus x, and it tells you x is 3, so we're just doing 5 minus 3, which is 2. So we can do the same thing for each of these. For the second one, it's asking to find g of 0. So am I going to use x is less than 0 or x is greater than or equal to 0? I'm going to use greater than or equal to 0. So I'm going to use the same expression again, 5 minus x. In this case, x is 0, so it's just 5 minus 0, and that's 5. What about the third one? G of negative 3. Which rule am I going to use? Is negative 3 less than 0? Or is negative 3 greater than or equal to 0? Obviously, it's less than 0, so I'm going to use the first expression this time. The first expression is 2x, so 2x. In this case, x is negative 3, so I do 2 times negative 3, which is negative 6. So you're going to do the same thing to the other problems. You can pause the video and try it by yourself, or you can keep on working with me if you still need some more help. So yeah, let's do blue now. So this f of x is telling us the rules. If x is less than or equal to 4, do this. If x is greater than 4, do that. So in this case, f of negative 3, which rule do I use? Rule number 1 or rule number 2? We're going to use rule number 1 because x is less than or equal to 4. So we're using this rule. I'm going to use that expression, x plus 1. In this case, x is negative 3, so we do negative 3 plus 1, and that's negative 2. What about the second one? In this case, x is 4, so do I use the first rule or the second rule? Since x is exactly 4, I want to use the first rule. So again, I'm going to use x plus 1. In this case, it's just 4 plus 1, which is 5. Now for f of 7, which rule am I going to use? Is 7 less than or equal to 4, or is 7 greater than 4? Obviously 7 is greater than 4, so we're going to use the second rule this time. So x minus 2, which is 7 minus 2, so we get 5. So all you have to do for these piecewise functions is check out the rules and follow the rules. So the same thing works for the piecewise function graphs. Let's look at the first one. We have p of x, and we have two different functions. The first function is x squared, the quadratic function. The second function is x minus 1, which is a linear function. And how do we know which one to use? We look at the rules. The first rule says if x is greater than 1, then we're going to use x squared. The second rule says if x is less than or equal to 1, then we're going to use x minus 1. So let's start with the first rule. I'm going to do the first rule in blue. So for everything that's less than 1, the graph is going to, for everything that's greater than 1, the graph is going to be the quadratic function. So one easy way to graph it would be to start an XY table of values. You can also use a graphing calculator, but you want to make sure that you pick values that are greater than 1. So you want to follow that rule. So what's a value that's greater than 1? Let's go with 2. Let's go with 3. So if the function is y equals x squared, what happens when you take 2 and you square it? You get 4. And what happens when you take 3 and you square it? You get 9. So you can plot those 2 points. 2, 4, 2, 4, and 3, 9. So 2, 4 would be 1, 2 on the x-axis, and then 1, 2, 3, 4 on the y. So there's a point there. And 3, 9 would be 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And we know that the shape of the general shape of the quadratic is going to be curved. Well, just for fun, what if you did put in 1? If you put in 1, what would 1 squared be? It would be 1. So you would have an open circle at 1, 1. Let's make that blue because we're doing blue for this rule. You would have an open circle, and then if you connect it to your other circles, you would have that nice parabola curve that you know is a quadratic function. All right, so let's go ahead and work on the second one. Let's go ahead and use green for the second one. The second rule is if x is less than or equal to 1. So we can make an XY table. You can also use your graphing calculator, but it's not going to piece it out for you into the piecewise function. So you want to pick values of x that are less than or equal to 1. So in this last one, remember we kind of cheated. We did the 1, 1 when we knew that x was supposed to be greater than 1 but not equal to 1. This one, we're not cheating if we use the value of 1. So 1. So what happens to this function, y equals x minus 1, right? This rule here. If we choose 1, so we do 1 minus 1 is 0. So let's go to another value that's acceptable, something that's less than or equal to 1. So what's less than 1? 0. So 0 minus 1 is negative 1. Let's do one more point. Another number that's less than would be negative 1. So negative 1 minus 1 is negative 2. So now we can plot those points. 1, 0 would be right here. 0, negative 1 would be right here. Negative 1, negative 2 would be right here. And we know that this is a linear equation, so it's going to continue going down 1 over 1, down 1 over 1, down 1 over 1 forever. So then we can draw a straight line. That's not perfect, but okay. And so that's the graph. That's what the graph is going to look like as long as x is less than or equal to 1. So notice how there's this black line is sort of incorrect. So if you look real close, you can see that they're not touching. The blue function for rule number 1 is not touching the green function for rule number 2. So we have basically a half of a parabola in blue, and then we have a line in green. I think picking XY tables of values is one of the best ways to do this. Let's try the next one. If you want to pause it and try it on your own, you can, or if you need more help, we can do it together. So let's use blue for the first rule. The first rule says x is greater than 1. If x is greater than 1, then we're going to use this function. I'll start with an XY table. And remember, the function is negative 2x. So let's pick values of x that are greater than 1. So 2, 3, 4. And then we plug each value in. With with 2, we do negative 2 times x. Negative 2 times 2 would be negative 4. If we try 3, we would do negative 2 times 3 would be negative 6. If we try 4, we would do negative 2 times 4 is negative 8. So we have 3 points that we can go ahead and plot. 2, negative 4, 1, 2, negative 1, 2, 3, 4. 3, negative 6. And 4, negative 8. You can also put this into the graphing calculator and hit table, and it'll show you the x and y values if you have trouble calculating them or if you just want to double check. So we have a blue line here, and we know it's linear, so we can just keep on making dots if we want. As long as x is greater than 1, this is what the graph is doing. Now let's try the second rule. The second rule says if x is less than or equal to 0, then you use this function. The function would be y equals x plus 3. So let's make an XY table for that one. And we have to follow the rule. So we're going to pick values of x that are less than or equal to 0. So let's start with 0. Another one that's less than 0 would be negative 1. Another one would be negative 2. So we have 3 points there. If x equals 0, then we have 0 plus 3 is 3. If x equals negative 1, we have negative 1 plus 3 is 2. And if x equals negative 2, we have negative 2 plus 3 is 1. So we can go ahead and plot those points. We have 0, 3, negative 1, 2, and negative 2, 0, 3. Sorry, my 0, 3 is not right. That's 0, 4. Let's fix that. 0, 3 would be right here. I was looking at the line that was already there. Negative 2, 1 would be here. And this is linear too, so we basically know what it's going to do. If it was negative 4, it would be here, and so on. So we could draw a line. That's what the graph does as long as x is less than or equal to 0. So we have a filled in point here at 0. We should also fill in the blue line. So like we did before, let's kind of break the rule on the first one. Remember, it says x needs to be greater than 1, but let's just see what happens if x is 1. If x is 1, then we have negative 2 times 1 which would be -2. So let's fill that in and leave it as an open circle because it's breaking the rule. So 1, -2 would be right here. I should do that in blue. Blue, blue, blue. It's open because it shows that that point is not included in the graph. And then we can make a nice line here. So now we can see how our graph is behaving. It's kind of funny on this one because there's this middle zone. It doesn't tell us what happens if x is in between 0 and 1. So we have pretty much nothing in this whole area here. So that's kind of interesting. But that's sometimes how these piecewise functions work. All right. So we've graphed some piecewise functions. Now we can look at a graph and we can write the equation by looking at the graph. All right, so this, let's start with this first piece here. So where is that point? Where is that little black point? What's the coordinate of that little point? It's 1, 2, 1, 2, 3, 2, 3. All right, and it's a linear, so it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, basically forever. So you could make it longer if you wanted to. And you can also see where does it intersect with the y-axis. Where does it touch the y-axis? Right here. So what's the coordinate of that point? That point would be 0, 1. That's the y-intercept. And then we also have this point, which is the x-intercept. Let me make this line a little bit longer here. The x-intercept would be -1, 0. That's right here. All right, so now we just need to figure out what's the equation of this. This one's pretty easy. If you write it in slope-intercept form, y equals mx plus b. Remember that m is the slope. So obviously the slope here is 1, because every time you go over to the right, you go up 1. Right? Right 1, up 1, right 1, up 1. Right 1, up 1, right 1, up 1. So your slope is +1. So that's 1. And your y-intercept, kind of like we talked about, is right here, 0, 1. So if you want to write the equation of that line, it would be y equals 1x, or x, plus 1. So the first line, we have it. Let's write it as f of x. You can write f of x or g of x or whatever you want. F of x equals, you have a little bracket there. So our first rule is this rule, y equals x plus 1. Y equals x plus 1. When is that true? So that's true when x is less than what? What's the furthest, what's the biggest x value that you can see on this first line? What's the biggest x value? It's going to be the x value of that dark point, which is 2. And is 2 included? Is 2 going to be shaded in? Yes. So as long as x is less than 2, this is the line that we're seeing. So we put a comma. X is less than 2. Less than or equal to 2. And you could see for every value that's less than 2 here, that's what this graph does. Now let's figure out the other part of this. we're now looking at this horizontal line. Has no slope, so we know the slope is 0. We know that's 0. And the y-intercept, it doesn't have one because it actually doesn't touch the y-axis. But if it did, what would the y-intercept be? It would be 0, 1, 2, 3, 4. So if it has no slope, that's a 0. So it would be y equals 4, would be the equation of that line. Y equals 4. So we have the equation. And when is that true? For what values of x? Actually, I shouldn't be writing y on here because we're using the f of x notation, so we don't have to write y. It's kind of redundant. So it doesn't really matter, but it's just a little notation thing. So y equals 4, or f of x equals 4, and that's true when x is what? For all of these values of x right here, it's true. When does it stop being true? Whenever x is right here. And what's that x coordinate? That's x equals 2. So for all these points here for x, these are all the points that are greater than 2. So we write x is greater than 2. So we've sort of reverse engineered this to describe what's happening in the graph. The rules are, the first rule, if x is less than or equal to 2, then our graph looks like this. We have the graph of x plus 1. And whenever our x is greater than 2, but not including 2, that's why we have that open circle, then the graph behaves like this, which is f of x equals 4. So it's that flat line with no slope. So if you want to pause it and try the other ones on your own, you can, or you can continue with me. Let's look at this purple one. So let's start with this weird shape here. I actually see 3 different piecewise functions now. I see one line here, one line here, and one line here. So let's label them 1, 2, 3. Let's start with 1. Let's call it f of x, just because that's what we're doing, I guess. We're going to have 3 different things here. So we'll start with number 1. What is the equation of this line? If this line was a normal line and it kept going forever, what would its equation be? We can see that it has a slope of -1, because every time it goes to the right one, it goes down 1, right 1, down 1, right 1, down 1. So we know the slope is -1. And the y-intercept, right, with our y equals mx plus b, our y-intercept would be 0. So the equation for that first line would be y equals -1x or -x plus 0, which is just -x. All right. When is this true? What's the rule? This is true for x values that are, obviously we're in this on the left-hand side, so we're in a negative quadrant. So what's the biggest x value that's in this line? Right here. Because once you hit right here, you change to number 2 line. So this is 0, right? So as long as x is less than 0, that's how it behaves. So we have, as long as, oops, why does it do this to me? Why? As long as x is less than 0. Would it be less than or equal to 0? Since there's no open circle here, yes, we could put the underline because that would be included. So let's go on to line number 2. It's kind of a tiny line, but if it were a normal line, what would the equation be? The slope, what's the slope? The slope would be positive 1, because every time it goes right 1, it goes up 1. And what's the intercept? It would be 0, because it touches the y-axis at 0. So this equation would be y equals 1x plus 0, which is just y equals x. So we have the equation for the second line. F of x equals x. Put the comma and then put the rule. So when is this true? Now this one is true when x is between what two numbers? I'm going to zoom way in here and do some red. So this is only true between here and here. X value here, 0. X value here, 1. So it's true as long as x is in between 0 and 1. So we're going to have to write a conjunction inequality. X is in between 0 and 1. Oops. Stop doing this to me, iPad. Okay. X is in between 0 and 1. Should I underline any of those less than symbols? I should underline the first one, because the first one, as we can see here, is filled in. Well, I guess it's not really filled in, but it's not open. So that means that 0 is included and then 1 is not included. So 0 has an underline there. All right, now we only have line number 3. This is the flat line here. So what would be the equation of this line if it were a complete line? It doesn't have a y-intercept. It doesn't have a slope. The slope is 0. So that means y equals 0x plus, what's the y-intercept? If it was a normal line, it would be right here, which is 1, 2, 3, 4. So to simplify that, it would be y equals 4, or f of x equals 4 in this case. So we have the equation for that line, and now we have to write the rule. When is this true? This is true between these two x values. What's the x value here? 1. What's the x value here? I don't know. 1, 2, 3, 4, 5, 6, 7, 8. So when x is in between 1 and 8, this is our equation. So we're going to have to write another conjunction. It's in between (1) and 8. Do I need to underline these inequality symbols? Yes, because both of these little purple things are filled in, so I should underline those two inequality symbols. Circle my answer. All right, what is the last one? We have 3 here as well. Let's label them. 1, 2, 3. So you can try this one on your own if you want. You're gonna have 3, so I'm gonna leave some space. So first we wanna think about the equation of the first line. If it was a normal line, what would its equation be? We can see it has a slope of -1 because it goes down 1, right 1, down 1, right 1, down 1, right 1. So the slope is -1. And we see that the intercept is 0. So for our equation, it would be y equals negative 1x plus 0, which is basically the same as negative x. So we have the first equation. Now, when is this true? When does the line behave like this? What are the x values that make it behave like this? Let's do red. So in between this x value and this x value, we have line 1, which is the line of negative x. So what's this x value right here? Negative 1, 2, 3, 4, 5. Negative 5 and 0. So we can write that rule. It's another conjunction. So x is in between negative 5, and 0. When x is in between negative 5 and 0, that's how the graph behaves. Do we want to underline these? Yes, we do, because this is filled in, and that's not an open circle, meaning it is filled in. As long as x is in between negative 5 or 0, including 5 or 0, that's how the graph is. All right, now let's look at line number 2, right here. What is the equation of this line? The equation of this line would be positive. The slope is positive. It goes right one, up one, right one, up one. So that's, the slope is positive 1, and the y-intercept is 0. So it'd be y equals 1x plus 0, which is just y equals x. So kind of like the last one we did. So we have the equation of the line. When does it behave this way? Line 2 behaves this way between these values. This x value is 0, and this x value is 2. So when x is in between 0 and 2, that's how it acts. So 0 and 2. Do I underline these inequality symbols? I'm going to underline this one, but not this 2, because that is an open circle, so it is not included in that rule. All right, almost done here. Line number 3. What would be the equation of this line if it was a normal line? It looks to me like this slope is negative 2, because it goes down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So the slope is negative 2, and it doesn't really have a y-intercept, but if it did, it would be right there at 0, 10. So the y-intercept would be 10. So the equation of that line would be negative 2x plus 10. Negative 2x plus 10. And now we want to write a comma and write the rule. When is this true? When is the graph negative 2x plus 10? It's in between this x value and this x value. So we know this is 2, and this is 3, 4, 5, 6. When x is between 2 and 6, that's the equation. So we do another thing, another conjunction here. 2 is less than x is less than 6. Do we want them filled in or underlined? Yes, because those both are filled in circles. So that is it. It's kind of a lot of work. You have to just think about the rules and look at the different pieces.